Next up, we have Martin from Avalanche. I'm looking forward to this one. Take it away, man. Thank you.
Work,
Is it the other clicker?
yeah.
Yeah, it's
Oh, it's another one.
this one. Sorry.
Oh, there we go. 2 clickers.
Yeah, I like to confuse my speakers.
Awesome. Thanks everyone for showing up. I'm Martin. I'm from the Avalanche team. The company building the Avalanche client. And very happy to talk to you guys about privacy today and how that can be implemented. And I think if I have one thing to say to you is, so if you remember one thing, it's don't reinvent the wheel, right? Like we see many blockchains implementing privacy today. And what we see is they implement a lot of things they don't necessarily implement, because what I think is privacy is mainly on the execution layer, right? So maybe you don't have to reinvent like consensus layer, networking, all this kind of thing. But let's start. So kind of like just to give you a feeling of what Avalanche is, right? Like we had like the first generation of blockchains, which are single chain, single asset, Bitcoin, Zcash, right? Like there's a very limited feature set to the blockchain. And then eventually Ethereum came around, and now we have multiple assets on chain. We can do all kinds of things with smart contracts. And then the third generation of blockchains we see today are multi-chain networks. So it's very important the distinction here is now you have multiple chains in a single network, and all these chains can cater to different use cases, right? Some may be catered at enterprises, some may be catered at gaming or whatever, right? And there may be also some that are catered towards privacy, right? And it's really important to understand like how this is different from a single chain system, right? Like where you have only a single chain. And if you're familiar also with other stacks, you know, like Polkadot, Cosmos, OP, layer 2s, layer 3s, it's a similar idea, but there are slight nuances, which I will talk a lot about in a little bit. So the general idea with these multi-chain networks is that you move from a single blockchain with one validator set and a fixed set of features to a network of different blockchains that can implement different things. And how does this look in practice in Avalanche today is we have the validator set of the Avalanche network. They all validate the primary network. If you think of it as a highway, right, a blockchain as a highway, then we can just build multiple highways in parallel. So these are completely independent by taking subsets of the validators and just adding them, and there can be overlaps and everything. But the beautiful thing about it is we can get a lot of throughput, but keeping short time to finality. How is this different from layer 2s? Each of these blockchains is independent and is not settling to a layer 1, right? So each of these blockchains is a layer 1. And why is this important? Because we want to achieve fee isolation. And why is this important for privacy? Because privacy is expensive, right? Like usually privacy involves some kind of cryptography. Cryptography means computation. And if you go somewhere in the developing world and say like, hey, you can do private transfers, but each transfer costs you 80 cents, they're going to look at you and be like, thank you very much, but that's not happening. So what does a fee isolation mean? Generally, fees mean, if you think of a blockchain as a highway, many cars on the highway, we'll raise the fees, right? We want to disincentivize people to use the highway. So if we have little to no cars on the highway, we're going to incentivize people to use the highway. So we are making it cheaper, right? Like, so think of it as a highway that has a toll that varies with the demand. So how does this look in practice, right? Like, let's say the first highway here, lots of users, the gas fees go up and the other ones are going down. And each of these highways can have its own gas token. So even if the underlying asset, you know, like fluctuates in price, you know, 10x bull market, everything is great. This is actually terrible news for the users because transactions get very expensive now, right? Like in dollars, right? Maybe not in the asset itself, but in dollars. Or yeah, that happens too sometimes. And now, so we talked about a little bit about fees, so how we can kind of manage the whole situation around privacy is expensive, right? Like moving privacy off, putting it on the shoulders of multiple chains can make it easier for the computation. But one very important thing is also customizability, right? Like, so maybe, you know, like our highway is great, but in some instances, we want to enable different modes of transportation. Traveling by boat, traveling by train. This is very easy to do in a multi-chain network, very hard to do on a single-chain system. So that's why you see many of the privacy solutions we see today on its own blockchain, or ASIS, right? Like, it's quite hard to do something like this on the Ethereum mainnet. So one thing you can do is, obviously, you can put up an EIP with some new novel cryptographic protocol. But this process will take a lot of time, and it will be, you have to really bring like broad community consensus that this is a great idea and that you want to merge it into Go Ethereum. So if you have your own chain, you can do that pretty quickly, right? Like, because you just have to align a small community around that chain. If you look at the stack of Ethereum, you can see Solidity, EVM, Gasper, there's like the smart contract layer, the execution layer, and the consensus layer. In Avalanche, we have these different chains, and what you can see is we have like one shared consensus and networking layer, but each chain has its own execution layer. So how does this help you with privacy? So there is something that you can now do. You can tweak this execution layer to your needs. Let's say, you know, you have some researcher comes up with a new cryptographic protocol. Instead of now putting up the EIP, waiting for a year, you can just build this into your execution layer and use this whenever you feel like it, right? So how does this look in practice? I don't want to get too technical, but the general idea here is precompiles. Has anyone here heard of precompiles before? They are also common in Ethereum. Yeah, I see one. Okay, think of it as a general idea of taking a Go library. Golang is a very popular language, right? Like also in Web 2. So every cryptographic protocol is basically implemented in one of these languages, Go or Rust first. Wrapping that in a Solidity interface, making it available as a smart contract. It's not really a smart contract, but something like this. So with this, it's quite easy for you to make all these protocols without re-implementing them, just available to your EVM. In contract, that looks something like this, right? We have SHA-256, and you can see that we are interacting with it as if it was a smart contract, but it's actually not. If anyone's interested in this a little more, I'm happy to jump into it later. This is how the precompile code looks then, but yeah. So what's the idea here, right? We can really optimize performance by reusing well-audited and very well-optimized Go implementations in Solidity smart contracts, right? We don't have to re-implement them. We never want to roll our own crypto, right? So we can just use that. And we also have can increase interoperability by using cryptographic functions of other networks. But actually, you can even go one step further, right? You don't even have to stick to the EVM. So you can also come up with your own virtual machine, maybe Move-based, maybe Rust-based, and build these privacy features much, much deeper into the virtual machine itself, right? And this opens like completely new doors for you. But obviously, it's a lot more work than just building on top of the EVM. You lose all the tooling and everything, right? So I think the last thing is just like, the question is like, okay, like we are now distributing all this on different chains. We're having all these benefits of these different chains, but what is the downside of it, right? We are losing atomic interoperability. Now we are on different chains, right? So how do we solve for interoperability within the Avalanche network? And that is like the unique feature, I think, where we have native interoperability. I'm not going to get into too much details, but basically it's a simple public, it's like a asymmetric cryptography protocol where we just use kind of like the validators of each network as bridge wardens or bridge validators, so no trusted third party, right? And yeah, so this is kind of like the technical flow where we collect signatures from the validators, create a aggregated signature, and then submit it to the destination chain. Yeah, so if you want to learn more about like how to build these virtual machines, if you're a developer or just, we also have some non-technical courses. Highly encourage you to check out Avalanche Academy. There are like some courses. What we talked about today was mostly customizing the EVM. So these are both our non-technical courses, which help you to get started in general. And if you want to build in privacy, I highly recommend checking out our accelerator program. We're looking exactly for these kind of protocols that are consumer targeted. And it's 2 cohorts a year. There's a $50,000 stipend per team. We accept around like 15 companies max. And at the end of the day, there's a $400,000 prize pool for the teams. So if you're interested, please reach out or chat to me later. We'd love to see more privacy-focused teams. And yeah, would love to answer any questions. I think I made up some good time. Yeah, nice. Awesome. Thank you.
Are there any questions? What sort of projects are you seeing apply for these? I can't remember what you just called it. The
code base.
Yeah, exactly.
So I think currently we mostly see consumer apps, right? Like so, bringing more people on chain. Best case that weren't there before. Why is this the case? If we go back to the thought of fee isolation, having your own fee asset on your own chain, this actually opens the doors for Web 2 user adoption, right? Like Web 2 users, the concept of paying transaction fees is very foreign to them, right? Like you do something in a social media app, you click on a button, and even if it only charges you 5 cents, very, very odd. So all these protocols that want to onboard these users either have the challenge of explaining to them why every action now costs, subsidizing it, right? They just eat the cost. And this is like, both of these options are not so great. So what most of these apps are doing is now launch on their own blockchain with control over the fee asset, which makes it a lot more frictionless and doesn't force them to subsidize it, right? And that's what we see a lot. I saw an interesting project, a prediction market aimed at Web 2 users, leveraging blockchain to make it a lot easier with all the regulatory compliance, because they never hold on to the assets, right? Like, and it's all on chain, but the users basically have no idea.
I have a question, if I may.
Yeah.
So at the end, you talked about interoperability. My question is, so we have these multiple chains. There's probably a way how the chains communicate with each other, right?
Yeah.
And then you need to have some standard communication protocol or an SDK or something. But then since it's a distributed network, there's a problem of trust, right? So then you end up with some oracles or not.
Yeah,
or
that's a beauty.
this explodes, right?
Yeah, that's one of the larger differences between the multi-chain networks. For example, in Cosmos, it's a pure SDK, right? So you have no notion of the entire network. You have complete control over the entire stack, but you don't really have a notion of the rest of the network. In Avalanche, we have this thing called the P-chain, called platform chain. Basically, you can think of it as a registry of all validators in the Avalanche network. So basically a table of all, these are all the validators, this is their public key, and these are the blockchains they validate. So now the notion of this bridge oracle, we can actually just use the validators itself as their oracle instead of introducing a trusted third party, right? So imagine like it was really easy to have interoperability between Ethereum and Avalanche or any chain if you knew who the other validators were. Right, I'm more than happy to jump into it a little bit more in detail. But the general idea is, how can we reuse a trusted instance, like a trusted entity, for this interoperability without introducing the classical bridge wardens that are then hacked and all the money is gone. Very sad. Yeah, that's what we want to avoid there. Yeah, but more than happy. It's a little bit of longer discussion there, but more than happy to dive into it.
Thanks for the talk. If I understood it, the intersection with privacy is about lowering the computational cost of privacy. What are you looking for in terms of projects and privacy for Codebase? Is it specific ways for individuals to control the information? Is it for projects to become more privacy compliant? Just kind of tying it in with the legal talk earlier.
Yeah, I would say we are very agnostic about the actual use case. It's more for us like really enabling these new use cases, right? Like, as a technology provider, we are pretty low in the stack. And now we just want to enable kind of like the end consumer products that are leveraging this and that are doing something that is only possible, which isn't possible on Ethereum, even on a layer 2, where every transaction, can cost, especially the computational intensive ones, can cost quite a bit.
Have you had a privacy audit over everyone talks about security audits, and this came up on a panel earlier where someone talked about the concept of doing a privacy audit. Have you had that for this particular thing?
For Avalanche itself?
Yeah, for Avalanche, yeah.
So since Avalanche is only consensus and networking layer, there is no real privacy, right? It would be on the execution layer. And so far there is no meaningful privacy. So we do have one project in the pipeline. I think they are still in stealth, and they are doing private ERC20 transfers. Trying to solve the holy grail of, we all have ERC20s, how can we transfer them without anyone knowing, because everything is public?
Because I think and thanks for answering, I think one of the things that's come up a lot is just how users need to be able to choose their level of privacy in a way. And I think of the concept of a privacy audit is something that gives that potential user kind of some kind of third-party attestation of like, yes, this is actually private, because the reality is the end user never knows. And so, yeah, just a thought.
Yeah.
Time for one last question? No? Thank you very much. That was really good.
Thank you.